Hello everyone, welcome back to the channel. In today's video, we are going to understand a very important topic for beginners in IoT and embedded systems, ESP8266 NodeMCU versus ESP32. अगर आप बिगिनर हो या आपको ये कंफ्यूजन है कि प्रोजेक्ट के लिए कौन सा बोर्ड बेटर रहेगा, then this video is going to help you a lot. In this session, we will compare both boards step by step in a very simple language so that by the end of the video, you can easily decide which one is right for your project. So let's get started. First, let us talk about ESP8266 NodeMCU. ESP8266 is a very popular and low-cost Wi-Fi development board. It is widely used in beginner-level IoT projects because it gives you built-in Wi-Fi at a very affordable price. It comes with a single-core processor, limited RAM, and usually 4 MB flash memory. One important point is that this board supports Wi-Fi, but it does not support Bluetooth. Another limitation is that it has only one analog input pin. So if your project needs many analog sensors, then this board may feel limited. But for simple applications like smart switch control, sensor monitoring, or web-based IoT projects, ESP8266 is still a very good choice. Simple words में समझे तो ESP8266 is a budget-friendly board for basic IoT learning. Now let us understand the pinout of ESP8266 NodeMCU. Pinout समझना बहुत important होता है because this tells us which pin is used for power, input-output, analog signal, and communication. Here you can see pins like 3V3 and GND for power supply. Then there are digital pins like D0 to D8 which can be used for connecting LEDs, relays, sensors, and modules. The A0 pin is the analog input pin. Pins like RX and TX are used for serial communication. Also, D1 and D2 are commonly used for I2C communication. One important practical point is that some GPIO pins in ESP8266 are linked to the boot process. So while making hardware connections, always choose pins carefully. ये छोटी सी चीज beginners ignore कर देते हैं और फिर board properly work नहीं करता. Now let us move to the more advanced board, ESP32. ESP32 is a much more powerful microcontroller board compared to ESP8266. It comes with a dual-core processor, higher clock speed, more RAM, and more GPIO pins. The biggest advantage is that ESP32 supports both Wi-Fi and Bluetooth, including BLE. That means if your project needs wireless communication beyond Wi-Fi, ESP32 gives much more flexibility. It also supports multiple analog pins, touch sensors, DAC features, and better multitasking capability. So if ESP8266 is for simple low-cost IoT, then ESP32 is for more advanced and feature-rich projects. ESP32 थोड़ा powerful version है, जो bigger and smarter projects के लिए better है. Now let us look at the pinout of ESP32. At first glance, you can clearly see that ESP32 has many more pins than ESP8266. That means you can connect more sensors and peripherals without much limitation. Here you get multiple GPIO pins, many ADC pins, DAC support, UART, SPI, I2C, and even touch-capable pins. This makes ESP32 highly suitable for projects where you need multiple sensors, display modules, communication devices, and control outputs together. But again, just like ESP8266, some pins have special roles and some are input-only pins. So while designing the circuit, always check whether the selected pin supports input, output, analog or special functions. Practical projects में pin selection बहुत important होता है. Now comes the most important part, the direct comparison between ESP8266 and ESP32. If we compare processing power, ESP32 is much stronger because it has a dual-core processor, while ESP8266 has a single-core processor. In terms of RAM also, ESP32 gives better memory support. For connectivity, ESP8266 gives only Wi-Fi, while ESP32 gives Wi-Fi plus Bluetooth, which is a major advantage. When it comes to analog inputs, ESP8266 has only one analog pin, but ESP32 has multiple analog-capable pins with better resolution. ESP32 also supports features like touch sensing and DAC, which are not available in ESP8266. However, ESP8266 still has one major advantage. It is cheaper and simpler for beginners. So overall, if your project is basic and low cost, go with ESP8266. If your project needs more features and future flexibility, go with ESP32. So now the practical question is, which one should you choose? Choose ESP8266 if you are a beginner, your budget is limited, your project only needs Wi-Fi, and you are making something simple like a smart bulb, weather monitor, or web-based sensor node. Choose ESP32 if you need Bluetooth, you want to connect multiple sensors, you need more GPIO pins, or you are planning a bigger project with advanced control and communication. Very simple decision है. Basic learning and low budget ESP8266. Advanced project and more features ESP32. Before starting practical work, let us see what things you need. For hardware, you need an ESP8266 NodeMCU or ESP32 board, a USB cable, a breadboard, some jumper wires, an LED with resistor, and maybe a potentiometer for analog testing. For software, you need the Arduino IDE, the required board packages, the USB driver, and if you are doing IoT dashboards, then the Blink library. ये बेसिक सेटअप हो जाए तो आप इजीली प्रैक्टिकल स्टार्ट कर सकते हो.
Now let us understand the Arduino IDE setup process. First, install the Arduino IDE on your computer. Then, go to the Preferences section and add the board manager URLs for ESP8266 and ESP32. After that, open the board manager and install the respective board packages. If your project uses Blink, then install the Blink library also. And one very important step, make sure the correct USB driver is installed. Otherwise, your laptop may not detect the board. Many students face upload problems only because of missing drivers. So this step should be done carefully. Now we come to the first program, Blink LED. This is the simplest and most famous starting program in embedded systems. In this code, we define an LED pin, then in the setup function, we make that pin an output using pin mode. Inside the loop function, we turn the LED on using digital write high, wait for some time, then turn it off using digital write low. This program helps students understand three important things: how to define a pin, how to control output, and how delay works. अगर आप ब्लिंक LED समझ गए, तो आप डिजिटल आउटपुट कंट्रोल की बेसिक फाउंडेशन समझ गए. Now let us compare analog reading on both boards. In ESP8266, analog reading is done through A0 pin and the value generally ranges from 0 to 1023. In ESP32, analog input can be taken from multiple ADC pins and the reading range is larger, usually 0 to 4095. That means ESP32 gives higher analog resolution and more flexibility. But one important point for ESP32 users: some ADC pins may create issues when Wi-Fi is active, especially certain ADC2 pins. So if your project uses both Wi-Fi and analog sensors, then choose the analog pin carefully. ये practical point students को definitely याद रखना चाहिए. Now let us understand the communication protocols used in these boards. First is I2C, which uses two wires, SDA and SCL. It is commonly used for sensors and OLED displays. Second is SPI, which is faster and useful for modules like SD card modules and TFT displays. Third is UART, which uses TX and RX. It is useful for serial communication, debugging, GPS modules, and controller-to-controller communication. And fourth is Wi-Fi, which is built into both boards and is the heart of IoT projects. If you understand these protocols properly, then interfacing sensors and modules becomes much easier.
So ये slide आपके लिए बहुत important है from the project point of view. Now let us see what kinds of projects you can make using these boards. With ESP8266, you can build a weather monitoring system, a smart home automation switch, a web server, a soil moisture monitoring setup, or a basic IoT sensor node. With ESP32, you can make more advanced systems like Bluetooth-based devices, smart locks, voice-controlled systems, face detection setups, and multi-sensor monitoring hubs. So the project range of ESP32 is clearly wider. लेकिन beginner के लिए ESP8266 भी काफी useful board है. Now let us talk about common issues students face. If the board is not detected by the computer, then most likely the USB driver is missing. If code upload fails in ESP32, sometimes you may need to hold the boot button during uploading. If Wi-Fi is not connecting, check whether you are using 2.4 GHz Wi-Fi, because these boards usually do not work with 5 GHz networks. If Blink is not connecting, verify the auth token and internet connection. If analog reading is wrong or zero, then check your wiring and make sure voltage levels are correct. And if random reset happens, then it may be a power issue. So electronics and IoT projects always need patience. Error aana normal hai. Troubleshooting is also part of learning. So let us quickly summarize the complete topic. ESP8266 is simple, low cost, Wi-Fi enabled, and best for beginner level IoT projects. ESP32 is more powerful, has Wi-Fi plus Bluetooth, supports more GPIOs and analog pins, and is better for advanced applications. So the selection depends on your project requirement. अगर project simple है, budget कम है और learning start करनी है, ESP8266 is enough. अगर आपको powerful board चाहिए with more flexibility, ESP32 is the better choice. So that's all for today's video. I hope now the difference between ESP8266 NodeMCU and ESP32 is much more clear to you. अगर आप beginner हो, start with simple experiments, understand the basics, and then move to advanced projects. If you found this video useful, then do not forget to like, share and subscribe to the channel. Comment करके ज़रूर बताएं कि आप next किस board या sensor पर video चाहते हैं. Thanks for watching. See you in the next video. जय हिंद.